So we're having 3 sessions, a break at 10:30, coffee break, and then lunch will be provided outside. I've tried to group speakers by areas of interest. I wanted to say one thing at the start, which was that there's a lot of stuff going on campus. So there is a data science initiative, and that's looking to develop a data science minor at the undergraduate level, graduate designated emphasis, encourage courses. There has been the university's had a hiring incentive program, okay. 3 of 9 were awarded to data science oriented things. So in particular, this data science research and academic programs, there's a hope that eventually there'll be a program or department within letters and science. And these other 2 are also related to data. The business school is starting a Master of Science in Business Data Analytics, which to begin with will be in San Francisco, but ultimately it'll be here. The statistics department has 3 new data sciences courses at the undergraduate level, right? So there's a lot of stuff going on. Okay, so the first session are studies which I would say from an economist's point of view, which I am, are non-economics, and maybe with a psychology bent. Right, and the goal of this is we see different types of work. And our first speaker is Jing Wen. And so why don't you come on up from communications. And this screen is pretty small, right? So, and we have plenty of room. So if people want to move up to where it's easier to see the screen, feel welcome to do that. Okay, so the plan is each speaker has 30 minutes. If they finish in 25 minutes, which I recommend, then we have time for a bit of feedback too. Okay. Oh, there is a clicker. Yes, there is a clicker. You could, okay, so what you should do is put this mic on. Sorry. Okay, maybe I need to just type this.
Hello everyone. Thank you all for coming this early Friday morning to attend my talk. So I'm very glad to share my research with you all. I'm Jingwen Zhang. I'm a new assistant professor at the Department of Communication. I just joined the University of Davis this June, so it's my first time to coming here. So I'm very excited about starting my research at UC Davis. So today I'm going to talk about my research in the past 3 years. So the general idea is to use an experimental approach to study network social influence in offline behaviors. So I will present 3 studies, and I think the goal for you is to just to know how I do research and how we use persuasive technologies to change people's behaviors in real-life settings. So the basic theoretical foundation for this work is social influence. And we know that social influence has been studied on different levels, both on the macro level about interpersonal communication and the macro level on the level of social networks and how social influence diffused in social networks. We know that classical work from psychology and communication have examined a lot of personal influence techniques, like Cialdini talked about a lot of language strategies in persuading people to do stuff. And Adolf Katz from the Edinburgh School had this classical book about personal influence, mostly in political context. And on the macro level, in recent years, social network has been becoming a very hot topic, and also in communication, there are a lot of work done to understand how people communicate with each other in their immediate and also extended social networks. Books like Linked and Connected have attracted a lot of attention, and the argument is that your behaviors and ideas and beliefs are not influenced only by your friends, but also by the friends of your friends and of their friends. So just to give a very simple example about smoking. Smoking oftentimes happens in social settings, so people sometimes smoke under the pressure of other people. In certain cultures, like in China, smoking can be set up in different contexts to give pressure to other people. For example, on a dinner table, offering cigarette to other people sometimes show respect and effort to build relationship. So in that context, you may not be able to resist taking the cigarette if even you don't smoke. On the macro level, this study by Christakis and Fuller in 2008 showed that they tracked 1,000 people from 1971 to 2000 about their smoking status. So clearly we can see from this diagram that smokers were clustered in their social networks in 1971, and when the social norms about smoking shift, and when we look at their networks in 2000, and we can see that many of the non-smokers, previous smokers became non-smokers, and then the green notes show the non-smokers, them become clustered together. So this is just a basic idea that we're looking at social influence at two different dimensions. One is on the interpersonal level and the other on the social network level. And we can clearly observe the behavior clustering in social networks, demonstrating social influence among our circles of friends and family members. For me, my research question is how to design persuasive technologies that leverage network social influence to change behavior. So from a communications perspective, we're looking at how to design, for example, websites and mobile applications to change people's behaviors utilizing their social influences in their social networks, either real social networks or constructed social networks from an experimental approach. The behaviors that I'm looking at and we tested in the previous studies is focusing on physical activity to address the problem of sedentary lifestyle. If you know the statistics that about 38% of American adults were obese in 2013 and 2014, and Americans on average took 5,000 steps a day. Do you know how many steps you take per day? More than that or less than that? More than that, okay. And about 69% of young Americans failed to meet the national guidelines for physical activity in 2014. So sedentary lifestyle is very common also among certain ethnographic minorities. So we're going to see how our experiments can change people's physical activity behaviors. Previous interventions in promoting physical activity focused on different strategies, including mass media campaigns, behavior interventions, and financial incentive interventions. And in recent years, there are more programs focusing on e-health and health interventions, including online forums for people to exchange information about how to increase their fitness. And also, you know, all these wearable devices people can wear, like Fitbit and Jawbone. And those devices are connected with apps, then people can track their physical activities and compare with other people. Like showing here in this picture, if you're using Fitbit, you can add other people as your connections, and then you can compare your of steps and miles and calories to other people. One issue with this self-initiated social connections is that individuals' choices oftentimes limit the value of their online resources. People often select a social context based on similar characteristics, including fitness levels. So this basically is based on the idea of homophily. So you choose your social context based on similar interests and behavior traits. So if you are the person using the Fitbit, you connect with your friends and people that you know, and oftentimes your behaviors are on similar levels. So in this case, you have all these people, but your behaviors may be very similar to each other. Then from information point of view, you may not receive new information. For example, you may not know other people who are much more active than you or much more less active than you. So theoretical framework for our experimental approach is to see whether social networks can induce behavior outcome changes through different psychological mechanisms. So this model is a simplified model of the Berkman model on how to on social networks and health. The argument is that our social structure conditions, including political environment and cultural environment, influence the social network formation and then influence different psychological mechanisms that lead to behavior outcomes. So my research mainly focused on how to design persuasive technology to change people's social networks and then lead to behavior outcomes through psychological mechanisms. The approach is that we as researchers, we construct online social networks. So this is just a topology of how we construct people's online social networks. So for example, if you go to a website or you start to use an app and you start to see other social contexts, as researchers, we control who you can see, who will be your social context. So for example, if you are in a study and you're assigned a node here, so this represents you, and then your social connections are determined by us as researchers. So from experimental approach perspective, we can then manipulate the social network configurations for your social context, and then your information exposure will be determined by your social network. And any questions on this? No? Okay, so after that, we basically have participants in the experiments, and then they are going to be assigned into different nodes in the network. Just a little bit clarification. In this one, you can see the blue nodes and red nodes, and this is based on the algorithm that people will be put into as social contexts if they're similar in age, and this is male and this is female. Basically, we want to see whether homophily as an algorithm of social networks can induce better behavior change. Yeah.
Are you manipulating extant networks and controlling them, or constructing like a network online from scratch?
It's from scratch. It's a totally new network because we don't want to confound people's existing network characteristics with our experimental manipulation. So all this construction is from scratch, and people come into the study, they start the program as basically seeing new people from their environment.
So do the people know that they're part of an experiment?
Yeah, but they don't know exactly like where they are. So this is unknown to them. So when they go to the study, you will see how it looks.
Okay.
Like. Yeah, and then so this study is longitudinal. So then we observe people's behavior change over time in their location in the network. So in study, I'll talk about 3 studies, and this is study 1. In study 1, we want to compare 2 different approaches in promoting behavior changes as the first step to see whether constructed online network is more effective or less effective than like traditional communication strategy like media messaging. So in the media messaging condition, we basically give people messages like promoting physical activities. Like this message from CDC saying that you need this amount of activities to gain health benefits. And the assumption is that individuals are independent from each other, receiving the messages from the researcher. And in the online social network, as I just explained, when participants came into study, they're assigned into different conditions, and then they're connected with each other. This is just a topology and not the exact network configuration. Because in the study, people are assigned to networks with either four to six individuals because it's a large network. And not everyone has the same degree of connection. And then, so the idea is that if one person changes his or her behavior, all the other connections will receive the behavior signals from that individual. So for example, this person starts to attend a yoga class, and then attending yoga class as the message signal will be pushed into all the connections of that individual who starts to exercise. And then you can then envision, so if the signal changes this people's behavior, then the behavior change will cascade into the rest of the network. So this study was done at the University of Pennsylvania, where I did my PhD program. And it was a 13-week fitness program at the university level, and we collaborated with the Recreation Center to initiate this program. So it's a real field experiment. The Recreation Center offered 49 free classes, and we designed a website for the participants to enroll in classes as the experiment. And the primary outcome we're looking at is the number of online class enrollments. So when the students enroll in the program, they could use the website to register for access classes. And we use that digital behavior as an outcome in this study. And after they enroll in the class, they also show up in the classes. So we know that because the trainers track whether they attended the classes.
So is a class just like a 1 hour class, or is it a whole quarter long?
So there are 49 free classes through the SIP semester, and individual can choose to attend as how many as they want. So one class is 1 hour.
One class is 1 hour. Okay,
Yeah,
fine.
it's just
Right,
a
okay,
training
fine.
session.
Okay.
Yeah. So they just have multiple opportunities to attend the classes. So we also included a control condition that this is the very basic website the participants would say when they attended the experiment. So they would log into the website, and these are the classes informations, and then we register. This is the tracking of how many classes they registered and attended. So that's the control condition only for the individuals to register classes. In the media messaging condition, the basic website is the same for the individual to use. And then, but on a weekly basis, they receive the promotional messages through their emails and on the website as well. So this is just an example of an email, including how to do burpees, that's a promotional message, and all the class information included in the email as well. In the online social networks, so individuals were assigned with, in this case, 4 social connections. So here they could see how other people were performing in the program, also receive real-time signals about how other people were doing. For example, this email says, "Dear Olivia, your buddy has just registered for the following class," and then giving the class information. So if, for example, if we're all in the same network, and if I register for one class, you all will receive that behavior notification through your email, knowing that I'm going to the class, so maybe you're inspired to go to the class as well. And this is the distribution of class enrollments. We enrolled 217 students, majority of them are females. And here we can see that for the fourth quotile for the participants who attended more than 6 classes through the semester, there was significant difference between the online social network condition with the control condition. So in this case, the argument is that for people who are in the same network, if individuals started to attend more and more classes, that will form a reinforcing loop of behavior change. So that specific network performed much better than individuals who are in the control, who just do things on their own. And if we look at the cumulative class enrollments throughout the whole program, this is for the control. So it's the cumulative class enrollments for all the participants who are assigned into the control condition. And this is for the media messaging, and this is for the online social networks. So from this diagram, we could see that in the first half of the program, we didn't see much difference between the messaging condition and the social network condition. They were almost the same, but they were both significantly more effective than the control condition. In the second half, however, the social network condition showed more effects than the media messaging condition. And it was significantly more effective than the media messaging and also more effective than the control. Yeah.
I might have missed this. Would you please clarify when 2 slides ago when you were talking about this specific information via Olivia, when did that happen? Did that happen throughout the program or at some specific point?
So it's, I would say it's throughout the whole program, but also at specific time. That means that, for example, if I'm Olivia and you're the Coco Snell, which is the username. So if I register for one class and we're a connection, whenever I register for the class, you will receive my behavior notification. So for example, if I register 1 week this week, another one class this week, another class next week. So this week you will receive the notification, next week you will receive the notification.
Got it, but that happened throughout.
Throughout, and also in real time,
Got it.
meaning that whenever I did something on the website, you immediately receive that email. So it's throughout the whole program. And it's based on how many times I register and how many times you receive the email. Okay, so that was the first study, and we're glad to see that this kind of trend for the online social networks to perform much better in the later half of the program, because that shows the reinforcement effect that once people start to get active and more people get into the state of being active. In study 2, yeah,
Sorry, can you go back a second?
yeah,
So this is cumulative across the whole group of people?
yeah.
Because you've got your numbers, your cumulative numbers are around 300 to 400 at the end, but I thought from a couple of slides ago that most people didn't even take 6 classes over the course of the whole 13 weeks, is that right?
That's right. So we had a bunch of people who were mostly inactive in the study. So the effect,
So this effect is being driven by a few people?
right, driven by the people who are really active, and that also makes sense because when you think about the dynamics of social influence, as people start to active, their network gets activated of being active. If people, for example, are really sedentary in their social contact, the activation won't be active. The physical activity won't be activated. Yeah.
Well, you said you had 217 people.
Right.
Does that include those who did nothing?
Yeah.
Okay.
Yeah, that's the total sample.
So it is a small group.
Yeah, it's a
Yeah.
small.
And then how is that group picked?
We didn't pick the group, so we just recruited participants into the study and assigned them randomly into in network conditions.
So these are any students who chose
Yeah,
to take an
Yeah.
extra class
right, right.
or
So
were
the-
interested in, yes.
Yeah, so there was no selection bias when they came into the network positions. Yeah. Okay, so in study 2, we then looked into the social mechanisms that could be primed in their social network conditions. So we compared 2 mechanisms. One was social support, one was social comparison. These were 2 common strategies used in physical activity promotion interventions in the literature for public health and health communication. The social support idea is very simple. People want to help each other out with behavior change. So you can exchange information and emotional support, or sometimes can give very detailed suggestions about how to change behaviors or maintain behavior change. And social comparison is that people sometimes look up for other people's behaviors and get inspired about changing their own behaviors. So very different 2 approaches, and we want to compare whether they could be utilized in online social networks to change behaviors. Again, the same program infrastructure. This time, the second semester, it was 11 week, and the Recreation Center decided to offer more classes. So this time it's 90 free access classes, and again, we use the same website for students to enroll in classes. The primary outcome is the outcome class attendances. Again, we looked at the number of class enrollments as well, but this time we also looked at the number of class attendance. Basically meaning that in the first study, when students register for the class, they may not necessarily show up for the class. But in the second study, we looked at the class attendances as a stronger behavior indication for the behavior change. In this study, we had 4 conditions. It's a 2x2 design with a control condition, basic website. Social comparison is manipulated that it's the same as in the first study in the online network condition. So individuals used the basic website, and they were also assigned 5 other peers to see 5 other peers' performances. In the social support condition, individuals got to the basic website and they were assigned into a team with 5 other teammates. So basically that means they were told they would be in a team to complete this fitness program. And they were also provided a chatting box that they could exchange information and emotional support. In the combined condition, meaning combining the incentive of social comparison and social support, individuals used the basic website to enroll for class, and they were assigned into a team with 5 other teammates as well. But also in this condition, each team could see 5 other teams' performances. So basically here, in your own team, you can exchange support with each other, but also your team is competing with other teams for making better performances in the program. And also individuals could chat with their team members. So in these 2 conditions, individuals were competing for themselves as individuals. But in the other 2 conditions with the team, so individuals were given chances to talk with each other and also give support and compare their performances with each other as well. So you can see the websites looked almost identical from the first study, but here in the team support condition, individuals were now in a team and then they can exchange information with regard to the class. Okay, and social comparison is they don't have the chat, but they can compare their individual performances. In the team comparison condition, these are the team performances. So if this your team, you could see 5 other teams, and your team is competing with 5 other teams. So the results are very clear that the 2 conditions with the comparison incentive perform much better than the other 2. They control all the social support, and the social support really didn't work for physical activity promotion at all. And this is the cumulative class attendances again. So clearly, the combined and social comparison perform much better than the other 2. Very briefly about the third study. So the third study is a mobile app based on a social network intervention for African American young women conducted in Philadelphia. So this time we used the Fitbit, so we gave participants the Fitbits. And now we designed an app called PenFit to track information from the Fitbit that participants wear. And now we just have this co-infrastructure for gathering all the data from Fitbits and the app. I'll skip this. So the study designs that individuals again and online social networks again. So very basic idea, because this time we're extending the program to a different population, so we want to keep the experimental design very simple. So this is what the app looks like. Individuals will track their own activities on a daily basis, day to day, and this time in online network, they also see other people's performances. So same idea, but implemented in a mobile phone situation. And this shows the mean login numbers of the app by day and by experiment conditions. So we could clearly see that throughout the whole program, the login numbers decreased, but the online network decreased less than the control condition. So basically, people in the online networks would log into the app some more because they have other social contacts. If they're on their own, they're less likely to log back into the app. And we found a significant effect that our condition increased achieving 90 active minutes goal in comparison with the individual control condition. So individuals in the online network with 3 other women would do better in achieving the goal that we gave them in the program than the individual control condition. So some discussion and conclusion. We found that online network intervention can increase young adults the fitness program engagement, and also different framings and designs induce different levels of social influence. And lastly, more research is needed to examine mediation effects through psychological mechanisms. pathway. So in the second study, we designed the interface to induce different psychological states, but we actually didn't measure their using like survey methods to ask them questions whether you feel more supportive or you feel more competitive. So future research should ask those questions and see whether that's the real mediation mechanism for the effects that we observed in the study. So here at UC Davis, I'm extending this program again, mostly using mobile apps because now we can get a lot of behavior traces data from their mobile phones and also the devices that we give them. So that's all about my research. And I know it's a lot. If you have questions, you can approach me individually and talk about future collaboration opportunities. Thank you.
Thank you. Okay, we have time for one or two questions. If anyone wants to ask any questions? Yes.
Thank you for your presentation. These are really interesting studies. I'm wondering if you think any individual characteristics of the people in the networks that they might be comparing themselves to would influence whether or not they increase their physical activity over time.
Yeah, so definitely I
Oops,
think
I just
your
closed.
question can be tested with a moderation analysis to see whether individuals' characteristics would moderate the effects. So we didn't have those data, but I think it's very interesting to ask those questions in the survey before the study. But in this case, because all the individuals were randomized into the network position, so the results wouldn't be driven by their individual psychological states. Yeah, but you're right that if we had those measurements, we would see a moderation effect.
Do you have a way to quantify the extent of the results? I mean, some people call it effect sizes. Some of the results, although they are statistically significant, they seem to be on the small side. Is there a way to quantify that?
Yeah, so our effect sizes were very small, so small to medium, I would say. Because it's a field experiment, so we thought that even a small effect would be very significant for the effect that we see. Yeah, but if we were able to expand the programs on a larger scale, effect size would be still small, I think, because the manipulation was very minimum, that you only use the website, and all the manipulations were not like enforced as in lab experiments. Individuals just acted on the websites based on whether they the extent that they perceive these manipulations. Yeah.
So related to that, if you had a big enough sample, do you think you could go beyond just the summary of looking at like spillover effects? So what is the effect of friends of friends?
Yeah, yeah, we would be able to see that.
And are you hoping to get to that point, or?
Yeah, yeah. But I think in this case, when we construct the networks, it's not as extended as we observe in real life networks, that people have the extensions of connections. So in this case, it's only like one step further, so one social connection. But designing experiments in using larger and extended networks will be very difficult because you have to have a very large sample in order to have one observation about one social network. So in this case, one network was only like very small in size. The degree is 4 to 5 for each person. But if we're talking about extended networks with networks of size of 40, then 40 people would become one data point as an outcome. So then you have to have like thousands of people in order to have multiple observations about outcomes.
Okay.
Yeah.
Well, thank you very much.
Thank you.
Okay, next.
Yeah.
Okay, so next speaker is Nicole Sparapani, and I'll give you a 5-minute warning.
Okay, thank you. Excuse me.
Can
Really,
you
you want the
guys,
microphone or?
well, can you hear me if I'm talking
Yeah.
this loud? All right, I'm going to continue talking this loud. So my name is Nicole Sparapani. I'm also a new assistant faculty member. I'm in the School of Education, and I also hold an appointment at the Mind Institute. So I'm excited to be here today to talk to you guys about latent profile analysis. So just as an outline, I'm going to give you a very brief background on latent class analysis, and then I'm primarily going to go through one study that's looking at using latent class analysis in first grade students. And then finally, just a preview of latent class analysis in the ASD or autism population. Okay, so to begin, what is latent class analysis? I know some of you might know this really well, and others might know this not at all. So it's primarily a person-centered approach. That means that rather than thinking about examining a population mean, it's a statistical approach that looks at identifying different classes of individuals within one specific population. So why do we use latent class analysis? It's really ideal for heterogeneous populations. So the idea is that if you have a population, you want to know whether you really do have just one single population or do you have multiple populations within one data set. So moving from there. So the nice thing about using latent class analysis in educational research is that classrooms are very, very diverse. There's a lot of heterogeneity in classrooms. Students come in with varying strengths and needs, and we know that this idea of one-size-fits-all approach to instruction doesn't work for kids. So teachers are often faced with this problem where they're supposed to be individualizing their students' instruction to meet their unique needs. So latent class analysis is really exciting because it gives this opportunity for us to think about statistically how we can characterize patterns of students' behaviors. In the research literature, just recently, there's been a lot of latent class analysis happening in early childhood settings where we are just doing that, characterizing patterns of student characteristics in hopes to better social, emotional, and academic outcomes. By improving the instructional methods. So the first study that I'm going to talk to you about is a recent publication. It's called Latent Profile Analysis of Foundational Learning Skills Among First Graders. So the difference in terminology is that we refer to profiles when we have continuous data, and we refer to it as classes when we have categorical data. So this really came about by this need that we know that these school readiness skills are important in young kids that are entering school. So school readiness is a term that's used to really conceptualize a constellation of skills and behaviors and attitudes that students need when they enter kindergarten. And they're set to, it's said that they are set to set this foundation for learning. But then when we move beyond that kindergarten entry, there's really not a lot of data that says there may be variability or that these skills may be important for academic success. So there's this need to look at kind of that readiness beyond kindergarten. So for this study, we termed this as foundational learning skills, which represent this broad idea of school readiness. And the three main areas that we were looking into is social and emotional development, language, and self-regulation. So a little bit of detail on each, or background on each. Social and emotional development we know is important. It's been linked to academic achievement. And then the literature that talks about students that don't have the adaptive behaviors to cope with classroom change, they may exhibit problematic behaviors like externalizing and internalizing behaviors. That literature suggests long-term negative outcomes, whether social or academic. So this idea of social emotional development in the classroom is important, yet it is kind of a very needed area to research.
And same with language. So we know that language is important in the classroom. Students that have stronger language skills are typically better social communicators. Language is also related to reading achievement. And then with self-regulation, again, we know that self-regulation is important at school entry, and then there's been some research that says that self-regulation is important for learning outcomes. So this study looked primarily at two research aims. One, to evaluate whether there were distinct profiles that we could find within a sample of first graders. And two, we were interested in looking at whether there are patterns within, or whether those profiles differentially predict students' literacy achievement across first grade. So the data came from a longitudinal study on individualizing student instruction. Students were part of the larger study. They were in first through third grade. This study primarily just looked at the first graders. So there were 324 first graders in total, 28 teachers in general education classrooms across 5 schools, 45% male, between 5 and 7, just some descriptives. In regard to developmental abilities, the sample was fairly diverse. 14% had individualized education plans, and 36% were eligible for free and reduced price lunch. So that's typically used as a proxy for socioeconomic status. As for measures used in the latent profile analysis, we use the SRSS, the Social Skills Rating Scale, to look at students' social behaviors and problematic behaviors. It characterizes social behaviors across 3 domains: cooperation, assertion, self-control, and problematic behaviors across 3 as well: externalizing, internalizing, and hyperactive behaviors. As for language, we used the DELV-S, which is a screening tool that provides 2 primary scores. One that looks at level of risk, so the higher the score, the more risk that a student has for having a language delay or disorder. And then the other one looks at how variable their language is, dialectal variation. And then finally, for self-regulation, we use the head, toes, knees, shoulders task, which is a direct, individually administered fun little game that measures behavioral inhibition in students. Are you guys familiar with that at all? It's fun. It's fun to give. It's not really fun to take. And then for outcome measures, we use the Woodcock-Johnson vocabulary and letter word decoding subtest. So in order to identify latent profiles within this sample of 324 students, we compared models with 2 profiles, 3 profiles, 4 profiles, and 5 profiles. We used M+ software, and then we compared the model fit statistics and looked at the entropy. The idea is that, as for model fit statistics, the lower the better. For entropy, the values that are closer to 1 equal clear classification. So if you have a 1, that means you have very clear, distinct profiles. Yep.
So can you say just a little bit more? So first of all, which aspect of the data was longitudinal versus you just had one measure?
Excellent. So to go back, we were looking at profile analysis at the beginning of the year, just at the first measure. So the outcome measure, which was the Woodcock-Johnson, is the one that we're looking at the end of first grade. So the profile analysis is just for the beginning of first grade, with data used at the beginning of the year.
And then you're trying to predict
Right.
the measures of the next occasion.
Yep, yep. Okay, so what we found was that a 4 profile, latent profile was actually a 4 profiles best represented the data. So if you look at the numbers, you see that the model fit statistics are better than the 2 and the 3 profiles. If you look at the entropy, it's a 0.92, which is high. The reason why 4 beat out 5 profiles is because in the 5 profiles, model. So that's saying that the sample of 324 students can be divided into 5 subgroups. The 5th subgroup was very, very small. It was only a couple of students. And so the recommendation was if anything is under 1% of the sample, then it's not ideal. So we went with the 4 in this case.
So if I think of this as, say, a linear regression, we could just have one linear regression with one set of coefficients, 2 linear regressions with 2 sets of coefficients, and in that analogy, what you find is best is to have 4 linear regressions with 4 different sets of coefficients. Would that be a way of thinking of it?
I might have to process that. I'm not quite sure.
Yes.
So, yes, so the graph that I'm going to show you in a second will probably clarify what all of this is. So pretty much this is saying, again, you have 324 students. I'm looking at the beginning of the year. I have a series of variables. I'm looking at social behaviors, cooperation, assertion, self-control, externalizing, internalizing, hyperactivity, language, and self-regulation. And so I have this constellation of behaviors, and I want to know if they actually cluster differently in this sample, or if it's just one large sample.
So how exactly is this profile done? Is it a maximum likelihood estimation with finite mixture?
Yeah, so it's actually, so in M+, it's actually fairly simple the statistics. You're just identifying how many classes you want to observe. You're using maximum likelihood, and then you're asking for output in the end. It's a mixed model.
And then these labels that you're giving, like emergent hyperactive, this is
We-
after looking at what sort of people are in
Right.
there, and you provided those.
Absolutely.
Okay.
So again, this I probably should have shown you first, but this is where it makes sense. It started to make sense for me. So what we found is with our 324 students, we didn't have one population, we actually had 4 different subgroups or profiles of students, and they were characterized differently. So the majority of the students, 179, we called the GGS, we named generally good students. These are the students that teachers want in their classrooms. They have been Z-scored. So we're looking at everything compared to the sample mean. So slightly above typical social behaviors, overall very well behaved. The group of kids that I am most intrigued by is this one, the externalizing profile. These are the kids that I have been, as a clinician, called into classrooms for years and years. These are our guys that are exhibiting a lot of externalizing behavior in the classroom. They're exhibiting hyperactive behaviors, and they're not that socially, I don't want to say competent, that sounds mean, but they're not cooperative, that they don't have the self-regulation skills. And then the 2 groups that are also very interesting, this emergent hyperactive, which is the second largest group, they were exhibiting some hyperactive and externalizing behavior, and then some areas of weakness in social behaviors. And then finally, this internalizing profile, where the students were exhibiting more internalizing behavior than any of the other profiles, and less assertive behavior than any of the other profiles. And interestingly, in this profile, they had a higher risk for having a language delay or disorder, and their self-regulation skills were also lower than the rest of the group. So that's it for a minute. And then going back, we also looked at the probability of memberships within the analysis. We looked to see, do these students belong in these different profiles? What's the probability? And they were all very high. So for group 1, 0.937, that these students belong in the emergent hyperactive group, and very low probability that they belong in any other groups. And you can see that across each of the 4 profiles. So a few descriptives that are pretty interesting. In the emergent hyperactive group, where the students had some indication of the social and emotional risk, 50% were male, 13% had IEPs, 33% were eligible for a free and reduced price lunch. And then if you jump down here to that externalizing group, where the students had a lot of externalizing behaviors, mainly male, which is consistent with the research literature. But this is interesting to me, 0% of students in that group were identified. So they did not have an individual education plan. 50% were eligible for free and reduced price lunch. Generally good kids, higher percentage of female. Some students had IEPs, 30% were eligible for free and reduced price lunch. And then finally, in this last group where we saw weaknesses across all developmental domains that we looked at, 59% male, 11% had IEPs, and they had the highest percentage of students that had free and reduced price lunch. So then we next looked at the growth across the first grade years. We used latent class growth analysis, and the idea was just to see if these profiles could differentially predict their growth. We controlled for gender in SES, and again using M+ software. And so interestingly, that externalizing group, compared to the other ones, grew the most in letter word decoding, so they showed the most growth, significantly more than all the other profiles when it comes to letter word decoding. And then looking at their vocabulary, both the externalizing group and the generally good kids or generally good students group showed more growth in vocabulary over the course of first grade than the other groups. The emergent hyperactive and the internalizing group grew at less of a rate than the other profiles. So in conclusions to this study, we found that foundational learning skills do cluster differently among students at the beginning of first grade, and that these profiles did differentially predict their developing literacy competencies across the year. This is exciting because this idea provides some preliminary or some supporting evidence that a profiles-based approach might be helpful in identifying specific students that might be at risk kind of beyond what they're doing academically. And then for some future directions with this, we really want to understand this, I was excited about this study, but it's really just the beginning. It opens up this door for a lot of questions. And so really understanding the individual components and how they're relating to one another, if there is any one of those skills that are more important than the other, or if it really is kind of the pattern within these students. And then looking at the interaction with what's happening in the classroom environment. So we have teacher data as well, so we can see what the interaction is with what instruction, the interaction between instruction and how profiles change and grow in time. And then finally, to be able to use latent class analysis across different populations, which goes right into the next couple slides I'm going to show you. So I recently had the opportunity to use latent profile analysis looking at students with autism spectrum disorder. So I don't know how familiar you guys are with this population, but it is a wildly heterogeneous population. So across multiple developmental domains, students vary. So we, as part of this larger, it's called the Classroom Search Intervention Project out of Florida State, we looked at 196 students with autism, which for students with autism, this is a large sample. And they were in kindergarten through second grade. We used observational data, so we created this measure called the classroom measure of active engagement that evaluated specific learning challenges that we see in students with autism. So the examples here are looking at the, kind of how productive they are in the day. Are what we had coded for in this observational data was, are they doing anything that is productive? How many times they're looking up at their peers or they're looking up at their teachers, so that was tracked. How well they're responding, so not really with comprehension, but just are they responding when they are given some kind of bid or direction. And then their level of communication, whether they're directing communication or they're generating some kind of language. And then again, their level of flexible behavior. So we coded these behaviors within a sample, an observational video recorded data set. And again, just as an example to show you how cool latent class analysis can be with heterogeneous samples, we found that a four-profile model best represented this sample as well. So again, just briefly, the majority of the sample, 126 out of 196 of the students were not very actively engaged at all. And then 23 out of the 196 students showed a lot of eye gaze. So they weren't doing much else, but they were looking. So looking, but not really doing much else in the classroom. Profile 3 is pretty interesting, characterized by relatively more generative language over any other active engagement variable. And then finally, profile 4, 13 students showed fairly good active engagement compared to the rest of the profiles overall. So this is exciting because, well, actually, I'll go into that in a second. Again, the 4-profile model here showed the best fit overall, and the probability was very strong throughout. Entropy is very high. So again, this is very exciting because this is where my passion comes into place, working with and studying students with autism in the classroom context. And if we can start to identify these specific observable behaviors that students are presenting in the classroom, we can not only categorize these patterns, but we can think about how to match instructional opportunities to maximize that active engagement. I'm really interested in seeing in this population too how we can change active engagement and whether students, excuse me, whether students are actually staying within those profiles, or if that's something that's more fluid as part of an intervention. And that's it.
Thank you. Okay, so we did have time for a few questions. Any?
Yeah, I wondered if you consider how the different students were put into 4 different categories. If you think that's based on their sort of individual personality characteristics, or if you think there's some sort of social factors that are putting them in those different groups, especially since boys are more likely to be in one group and we have students with low socioeconomic status in other groups.
So there is some literature that, thinking about the typical population and looking at social economic status and how that's actually predicting certain things, right? And that's kind of a very common finding. And then with using latent class analysis, that has been something that has been predicting group in the past. So yes, I absolutely think that there are specific characteristics that are placing kids into groups, and there is some literature that is looking at that. For that first study, I did not look into that. For the students with autism, we have, the data set is just phenomenal. We have so many measures that are characterizing the sample. So we have, the autism symptomatology, we have intelligence, we have, there's just so many measures that really characterize the sample. So it would be very fun to kind of look at what is predicting membership, and then again, is membership stable across time? If it is something like intelligent, there's been recent literature that says even in students with autism, we can change intelligence. That's just a score that can actually developmentally be changed as students grow. So I think that it opens up the door for some nice future questions.
So, yeah. No, you go ahead.
Yeah. Do you have any idea how sensible is this is the classification with regard to the measures? If you were to take out some of the variables, so include some others, would you have a consistent pattern?
Right.
And if so, great. If not, I think it should be crucial to have
Absolutely.
a key theoretical measures that you want to use for classification.
Yeah, absolutely. So 2 comments. This whole idea came from practicing in the field, and seeing those guys in an externalizing profile and really conceptualizing and thinking about, as I'm practicing, what is important for learning, what are these foundational learning skills. So the tools that we used, again, this is just a beginning sample. One of our follow-up questions was to see how, can we replicate it with different measures using observational measures. Are these the key components, or is it being biased by a teacher rating measure, that kind of thing. So again, this is exciting, but it also is the very beginning. So our claims are minimal, but it provides some support that these profiles might be something important to think about in the future.
So I know you want to identify students and profiles, but when you did the prediction, how does it explain things over time? I thought that particular part of it would be well suited to machine learning methods. So particularly to use regression trees, right? You're looking at outliers. Right? And a regression tree will say, the first variable, if I split it in two, what gives the most predictive power? Right? And it might be, say, hyperactivity. And I thought that I only know these methods very broadly, but I thought, separate from your studies, that it might be interesting to apply to your data, regression trees.
That's where collaboration comes in.
Any other questions? Okay, well, thank you very much again. No, the problem is, let's go this way. That's you. Okay. And you've got. Okay. And do you want a mic?
No, I think I'm fine.
Okay.
Can you hear me in the back? Yeah, okay. Okay, so I want to talk today about how we measure psychological constructs. And yes, I'm focused on psychological constructs because that's my context. I do think that what I will talk about is more generally applicable, perhaps not to economists, but certainly to many social sciences. So I think, and what I'm going to argue is that we are steeped in the classical test theory assumption that every variable that we measure contains the thing that we're trying to get at, the construct we're trying to measure, as well as measurement error. And what I want to argue is that I think for a lot of the constructs we're interested in, that's not the relationship that we actually have, that we don't have a bunch of variables that all reflect one construct plus error, and that making that mistake has led us to some models that perhaps don't represent what we want them to represent. So consider measurement error. So this is classical test theory, the idea being that observed X and observed Y are a function of the true score X that we want to measure plus some measurement error, and the true score Y that we want to measure plus some measurement error. And we can get a little bit more expansive in this model, and we can add some specific reliable error that is not related, or not error, specific reliable variance that's not related to the construct. But we tend to accept and take for granted that every measure contains T and it contains E. And the problem with measurement error that we are all very sensitive to is that it gives us things like bias regression coefficients, right? If we want to estimate the relationship between construct X and construct Y, and we only have observed variables that are measured with error, then this regression coefficient of Y on X is going to be biased because it's not the same. It's not an unbiased estimate of the regression of true score Y on true X. And we know exactly to what extent that bias occurs, right? That bias is a function of, so this observed regression coefficient is a function of the true regression coefficient and the reliability of X. So the more error is present in X, the less our observed regression coefficient corresponds to a true score regression coefficient. And this becomes even more of a problem as our models get more complicated. So this is a simple regression, but if you look at something like a path analysis where you have one variable predicting some other variables, and those ones can in turn predict some other variables, you can have a model that has many variables in it, those various paths will be affected by measurement error in very difficult to determine ways. And so, for example, a regression path that connects two variables might be affected by the measurement error in some other variable in the model. And so we can get overestimated and underestimated regression coefficients, and this can be a real problem. And so the recommendation that's often given by methodologists in psychology and I think other fields is that we should get away from observed variable models and start relying more on latent variable models. So here's what a latent variable model looks like, your typical reflective latent variable model. And it relies on this assumption that we can have multiple indicators of every construct that we want to measure. So if X is some construct that you want to measure, but you have a scale and you have 3 items on that scale, then all you need is the assumption that all 3 of those items contain the same true score. So X1 and X2 and X3 contain exactly the same true score, and they contain different unique measurement error. Y1, 2, and 3 contain true score of Y and some other measurement error. And if we do that, this model allows us to disattenuate the regression coefficient of the error, right? So the idea is that what these variables have in common is the true score. That is the construct you're trying to measure. And if you can make that assumption, then it means that your latent variables represent exactly what you want them to represent. They are your true construct, disattenuated of measurement error. And so these models are so convenient that we start relying on them a lot. We think all I need is several indicators of my construct, and then I can get this model that lets me assess the construct that I want to assess without measurement error. So I want to focus, or I want to just point out 2 implications of the latent variable model that I think are, we don't often spend enough time thinking about. So the first is that all items have to share the same true score. So for example, if they capture diverse facets of a construct, those won't be represented. And so if you look at how we actually construct scales in psychology, what people often do is they actually pick items to try and get at disparate aspects of a construct, right? So they recognize that many psychological constructs are complicated and that they are multifaceted, they're not unidimensional. And so we aim to pick different items that actually assess all corners of a construct. And as soon as we do that, those unique facets of a construct are not represented in a latent variable because they're not shared among all items, right? So we violated the assumptions that allow us to use this model. A second implication is that all pairs of observed variables now are expected to be uncorrelated after conditioning on the latent variable, right? So the idea is that if you want to make a change in X1 or X2, you work through the common factor, the latent variable, right? So you can change the latent variable, and in so doing, you will change the predicted scores on all of the observed variables. If you change the construct, you expect everything on the scale to go up or go down. And if you change just one item on the scale, if you affect someone's behavior or someone's score on one item of the scale, you don't expect other items on the scale to change accordingly because there's no direct links between them. And so, whereas I think in reality for a lot of different constructs, there are direct effects that we expect. So if you were to change one part of a construct, one item that you're assessing, you would actually expect to see changes in some of the other things, right? So again, I think this model is violated more often than we expect. So I just want to mention that there are alternative possibilities. So I want to talk about 3 possible alternative construct models, and these are not the only ones, but there are some. So one is a causal indicator model. So it could be the case that your latent variable, your construct that you're interested in, is not the cause of the indicators that you see, but in fact it's the result of them, right? And so, for example, socioeconomic status is a really good example. We often measure socioeconomic status using the indicators income, education, and occupational prestige, right? And in this case, what you would actually expect is a compensatory relation among these things, right? You can increase income, and socioeconomic status will increase accordingly. Or you can increase education, and you would also expect socioeconomic status to increase. These things don't need to increase in tandem, right? Even though income and education are correlated, it's not the case that you need to, that increasing socioeconomic status requires increasing all 3 of these indicators. And it's also much more intuitive to think of socioeconomic status as a result of changes in these indicators rather than as a cause of changes in these indicators. A second possible alternative construct model is a mimic model that stands for multiple indicators and multiple causes, which is just a combination of the reflective model and the causal model. So the idea here is that you have some indicators that are better thought of as causes of the latent variable and others that are better thought of as reflections of it. So healthy lifestyle is an example here, where there are multiple behaviors you can assess that lead to a healthy lifestyle. So things like exercise, vegetable intake, and hours of sleep. These are all things that if you change them, they will lead you to be more healthy and not the other way around. On the other side, there are indicators that you could conceive of that are dependent on healthy lifestyle. So ratings, for example. So if you ask someone to rate how healthy are you, or how healthy is your partner, or ask someone's peer to rate how healthy they are, those are reflections, presumably, of someone's health, right? They're not causes of their health, but they're reflections of them. So there are two different kinds of indicators here, and sometimes we have access to these multiple indicators. A final type of analysis is a network model. This is sort of the most radically different kind of analysis, because now the construct we're interested in is not even pictured in the model, right? It's not a unique variable. But according to the network perspective, the idea is that it's sort of an emergent property. So here is a network analysis of depression. And the idea here is that the symptoms of depression have direct effects on each other. They have feedback loops. And that changing one symptom in a depression network will lead to other symptoms being different. So these things are not the result of some underlying depression construct that leads to changes in all of these symptoms simultaneously and independently, but instead they affect each other, and depression, the construct, arises from this system of interacting symptoms. Okay, so you might be wondering whether this is actually a problem, to what extent there are constructs that we're interested in that really fit these other alternative constructs. I don't have very much time to talk about it now. I did, just to answer this question for myself, I looked at the 6 most recent issues of 6 psychology journals, so the biggest ones. The most recent issue, I just found the first article in each that includes a structural equation model with the latent variable. And I looked at what sorts of variables were being modeled. And it seemed to me that, first of all, in every case, there was no justification given for the structure of the measurement model. So we tend to take for granted that if we have some variables, we can throw them into a reflective model and not have to justify that that's actually a reasonable thing to do. So at least in psychology, and maybe this is different in other social sciences, we take for granted that any set of variables that are related to the same construct can be put into a reflective latent variable model. And apparently reviewers don't have a problem with this, right? Secondly, in at least 4 of the 6 cases, maybe 5 of the 6 cases that I read, it seemed to me that the direction of the relation from the observed variable to the construct was questionable at best. And so authors were saying things like, we use the latent variable to represent the sum of these constructs, essentially, right? So they'd have a couple of different constructs, they would talk about them as discrete constructs, and then say, we wanted to use a latent variable analysis to represent the combination of these things, right? So people tend to talk about latent variables as a combination, and if you looked at the indicators and the latent variables that they were talking about, it often seemed much more plausible from a lay perspective anyway, from the perspective of someone who is not substantially in any of these fields, that a reflective model was not obviously the best model for, like I said, 4 or 5 out of the 6 of these models that I saw. And so I think this is actually a problem worth taking seriously, because at the very least we should justify to ourselves the models that we use before employing them. Okay, so what I want to know is, what are the consequences? And so I basically designed a simulation study just to look at what happens if we have data that are generated by some alternative measurement model and fitted to one of these, fitted to a reflective latent variable model. Okay. So in particular, what biases incurred. And so my model is a really simple one. I'm just having a mediation model where X predicts M predicts Y, and M, this mediator, I'm going to model it, generate data for that mediator according to 3 different models. Okay, so study 1. The model that I'm using is a causal model here. So as an example, suppose you have a mediation hypothesis where parent permissiveness leads teens to have more exposure to sexual media content, which in turn leads to higher rates of teen sexual activity. Right? Exposure to sexual media content is an example of a formative construct, right? So you could have indicators like teens' exposure to television content, internet content, magazines, and books, right? So 4 different kinds of media content which summed up together give you their exposure to media content in total. If that's the model, then what it means is that any effect of parental permissiveness on exposure is itself mediated by, through these paths, right? So it's mediated by these components. And so this is the model that I generated from. And in particular what I did is so these paths are labeled A1 to A4. I randomly drew 100,000 sets of values of A1 to A4, just from a uniform distribution. And then I solved basically for gamma and the covariances among these causal indicators, so that the total effect of X and M was constant at 0.6. So I was able to have a population value, and I could see in all of these different conditions what bias there was from that population value. For each set, I'm looking at the population covariance matrix, so I'm not actually generating any sample data, so I'm just looking at, given this range of different population values, what bias is incurred at the level of the population. And so for each covariance matrix, we fit these 2 models. So the composite model, where M is just a sum of the 4 indicators, and the reflective model, where M is modeled as a reflective latent variable with 4 indicators. Neither of these is the true model in this case, because M here also has some residual variance. And so modeling the construct is not just a pure sum of those indicators, but is the sum of those indicators plus a little bit. Okay, so to read these results, going from left to right, this is bias in the A path, bias in the B path, and bias in the C path. The horizontal black lines reflect the population value. Along the x-axis is the correlation among the causal indicators. And as you might imagine, as the correlation among these indicators gets higher, it becomes more and more appropriate to use a reflective latent variable model, because the latent variable then captures what's in common among them. So as they share more variance, that latent variable actually can capture more and more of the construct. And so what we see as we move from left to right is that the latent variable model, which is the results are this blue to red swarm of dots, gets a little bit more accurate. Along the y-axis is just the estimate. So the green lines reflect the composite model. And what we see is that in the composite model, there's a particular degree of overestimate here, which again comes because M is not just the sum of those 4 items. And we get a little bit of an underestimate here, but the total X to Y path is perfectly reflected in the composite model. And so we have a perfect estimate of the indirect effect. This is A times B. The color gradient from red to blue here reflects the amount of variation in these A paths. And so you can think about it a little bit like differential item functioning. So if X has a huge effect on M1 and no effect on M4, a latent variable model is going to have a really difficult time representing that different relationship. Because according to the latent variable model, X predicts the latent variable, and the latent variable predicts changes in the indicators. And so if X has different effects on those different indicators, then the latent variable model just won't be able to reflect those. And so what we see is that the bias increases to the extent that that differential item functioning gets bigger. Right? In general, what we're seeing here is that there's just a lot more bias in the reflective latent variable model than there is in the composite model. I also looked at model fit, and this is of the latent variable model, so the composite model fit perfectly. In terms of model fit, so this is on the y-axis we have just the population RMSEA, which is a 0 means perfect fit and higher is worse. And what we see here is there's actually no correlation in the latent variable model between the degree of fit and the degree of bias. And so in general, we're getting a lot of poorly fitting models. But those poorly fitting models don't necessarily correspond to the most biased results. Okay, just as a follow-up, so in that previous study, I had assumed that the indicators, x1 to x4, what I call them M1 to M4, were measured without error themselves, and that is a pretty spurious assumption, right? Most of our indicators of anything, at least in psychology, do tend to be measured with error. And so now I've just done a variation of this model where those indicators themselves have reliability of 0.8. So each one of those indicators, they're causal indicators, but they have, they're also affected by measurement error. All right. The true model in this case cannot be identified, so we couldn't fit the true model if we knew what it was. But I'm again looking at just the composite model and the latent variable model. And so what we see is that when those indicators have error variance, or they have less than perfect reliability, the green line reflecting the composite model now bends a little bit, right? So it has some additional sources of bias. The reflective model looks more or less exactly as it did before. Okay. In terms of fit, we now have a green line that reflects the fit of the composite models. We no longer get perfect fit, although it looks like very good fit. So it's very difficult to tell that the composite model is not the right model for the data. The fit of the reflective model is the same as it was before. Okay. Taking a different example, so this is a mimic model that corresponds to the multiple indicator, multiple causes example that I showed before. So now I've got 2 causal indicators and 2 reflective indicators in the generating model. And again, I randomly withdrew values of these 2 causal paths, and I randomly drew values of these 2 factor loadings. And we're going to look at all of those results. Again, fitting the same 2 models, and again, neither of these is the true model. Okay, so now in the top row, we have the results from the composite model, the sum score, and in the bottom row, we have results from the latent variable model. Along the x-axis now is the covariance between those 2 causal indicators. If we go back, just the covariance between M1 and M2. And the color gradient now shows the mean loading of these 2 factor loadings. Okay. So the color gradient is actually not very helpful in this respect. But what we see overall is that the causal model, the composite model does result in some bias, but there's very little variation around in what kinds of results you get out of the composite model. There's bias, but it's very little bias. On the other hand, there's much more variability in the results of the reflective latent variable model. So they're much more affected by the strength of those causal paths and the strength of the latent variable loadings. Okay. In both cases, the overall estimate of the indirect effect, so that's the A path times the B path, is roughly unbiased in both cases. So actually, in this, in many of these cases, the results using a latent variable model actually seems to matter less than you might think it would, right? Even though it's patently the wrong model for the data, so is the composite model. In both cases, we don't get a very biased estimate of the entire indirect effect. That's model fit. We get much worse fit for the latent variable model than we do for the composite model. Okay, one final example is a network type analysis. So I have a really simple network here where X predicts M, M predicts M2 and M3, and M2 and M3 together predict M4. Now I'm just going to be looking at the indirect effect of X on Y because there's no way to separate what the A path and the B path are when there's no one variable that represents the mediating construct. And so here it is. And again, we actually find that both of these models, although both result in biased parameter estimates, neither results in a very dramatic amount of bias, right? So both models result in an indirect path estimate that's a little bit biased. It's a bit of an overestimate, but not so strong. So the results are actually less dramatic than I had expected, and it could be the particular model that I've chosen Or it could be that latent variables, even though conceptually and theoretically they're the wrong model in a lot of cases, actually somehow manage to capture enough of the variance in the construct that they kind of work as a stand-in. So I want to conclude and say that the composite model showed equal or less bias in each of these cases than the reflective latent variable model. So it was never the case that the reflective model produced a better result. And obviously I'm only considering cases where the reflective model is not the right model, right? So when the reflective model is the right model, there's plenty of evidence suggesting, of course, that if you form a composite, if you form a scale and use that variable, when the true model is a reflective latent variable, you will get very biased estimates. But I guess what I want to say is that when the true model is clearly not a reflective latent variable model, you might be better off choosing to use a composite rather than a reflective latent variable. Whether or not the model is appropriate, of course, is a difficult question. I think it can often be answered by theory. At least to the extent that you want to know, is this a reflective latent variable, or maybe is it something else? Determining what the actual correct relationship among those indicators is can often be very difficult. That's it. Thank you.
Okay, so again, we've got time for a couple of questions. Okay, so I have a question, which was, I didn't quite see what the composite model was.
Oh, I'm
I missed
sorry.
that little bit. I mean, I didn't see it. It didn't register with me.
Okay, that's a
So
very
do we
important
just-
bit, I'm sorry. So the composite model, maybe I can even show it. The composite model is just the sum score. So M is just a sum of the four indicators. So
Okay.
this is M1 to M4. The composite model just sums them up. And so the question here is, I'm looking in each case at two options. Either you can
Okay.
just sum these variables up and use the observed score, or you can model a latent variable.
So the reason I ask this is that I think in economics, what we would do in that setting is we'd go with the first principal component of them, right? Or maybe the second. And essentially that's what your composite score is doing, right? It's summing them up.
Yeah, it's summing them up. I mean, your first principal component is not just a sum score. But it's
Yes,
capturing,
it's a
capturing,
weighted score.
it's a weighted sum. It's the weighted sum that captures the most variance, right? So the question then is the weighting correct? If the weighting is going to be
Yes.
based on
Yeah.
the shared variance. Now I want to add that condition.
Well, your composite is a unit weight.
Yeah, the
Yes.
composite
Linear
is-
combination.
Yeah, so it'd be interesting to see if you just let it be data determined in your simulations.
Okay, so
Right,
you're...
and so, classic book, very controversial book was the bell curve,
Mhm.
right, which looked at it, and it just used a single principal component, right, and then it used that to predict outcomes, right. So this is a book by Murray and Ernst, right.
So, okay, so at least in certain situations, though, that's not going to work, right? So if, for example, these variables are not correlated at all, your principal component is, well, what's your principal component is just going to be one of the variables, right? So the principal component is based on the concept of shared variance. And so if
Yeah.
they don't share variance, then your principal components analysis is not going to give you something useful.
So I wasn't guaranteeing that it was going to work,
No.
but I just thought that, we are talking about different approaches to data.
Yeah.
And in economics, generally people wouldn't use the latent class.
Yeah.
Your methodology, though, I think they would use principal components.
Do economists ever use latent variables?
In certain settings, yes. But for instance, it would be if you had like a multinomial choice, so you're choosing over 10 categories, and the errors are correlated, well then you have about 9 latent errors, and a big covariance matrix, it's just too hard to deal with, so instead you'd assume a latent structure for the error, just to collapse the dimensionality of it.
Okay.
Shu may know some other examples. It's used in in certain settings. But
In
it's
certain
not,
settings,
but
but
yes.
in a purely pragmatic way with
Yeah.
no meaning attached to latent variables. You might say.
Yes,
Okay.
yeah, I think that's, well, I'll think about it during the break. Okay, any other questions?
I have a very basic question.
Mm-hmm.
So thinking back at the beginning slides, so just conceptualizing or thinking about a latent variable, I remember when I took my first class in SEM, the instructor said a true latent variable, that every indicator has, like, you won't see a strong correlation between the indicators because everyone has its unique variance that it's sharing to that latent variable. Does that make sense?
No, that's.
So this is stuck in my head for years, and then, you know, I was going through and reading the literature. This is not something that you see over and over again. So I thought, because you were talking about high correlations between the indicators, when, so I guess I have two questions. One, I wanted to just kind of throw that out there because that's been in my head for years, that a true latent variable, kind of, you don't see those high correlations between the indicators because each one is contributing something unique, not necessarily
To the latent variable.
to the latent variable. And I mean, honestly, those were his words, a true latent variable. So that was one. So you're saying that that's not an accurate thing I should hold on to.
I would say not.
Okay. Is there any truth in that, or?
I don't know, I mean, it sounds like, so the latent variable, I mean, if you look at the math of what it's doing, is it represents the shared variance. So in the case where you have no shared variance, you cannot extrapolate
Right.
a variable, right? And if you look at like the factor loading, right, like typically in a latent variable analysis, you want higher factor loadings. The factor loading represents basically the square root of the covariance between each item and every other item, right? And so if you have low correlations among your items, you're going to have very low factor loadings, which is an indication that your latent variable model is not right, right? So yeah, I would say that's kind of the opposite.
Okay.
Yeah, that's right.
Well, and
That's
then-
exactly the opposite.
What is too high then? Because I've also seen, again, in the literature, I've seen really high correlations between indicators to the point where it's like, you know, is there ever a too high of a correlation of two indicators?
I mean, I think a too high correlation would indicate that you're probably just repeating the same item over and over again.
And
Right?
is that-
Like, in terms of reliability, in terms of the statistical model, it's great because you are getting at one unidimensional thing. You were getting at it with a high amount of reliability because you have items that are themselves highly reliable because they're highly correlated with each other. So, but I think there might be a pragmatic problem in there when it sounds like you're asking people 12 variations of the same item. That's what they call the bloated specific. So the idea is that you have your factor is probably something very, very, very specific, which if you're a statistician is a good thing, and if you're a psychologist is probably not a good thing.
Okay, so just follow up on that question on latent variables. In economics, we use latent variables as the Y variable, right? So it's generally not this stuff along the way, but the outcome.
Right.
And so one setting would be where the choice is between two alternatives. You'd have this latent utility for each, and then if one utility is greater than the other, then we'll buy the thing or we won't buy it.
Okay.
The second example would be where we're looking at expenditures on cars, and there's this latent desire to purchase a car, and if it crosses a threshold, then we'll actually buy it, but a lot of the data will be zeros, right? But we're not using things very much like factor analysis or mimic models and so on.
Okay.
Okay, any other questions? Okay, last question.
Thank you so much. I learned a lot from your presentation. So I'm more interested in the network model that when you present to the causes and relationships among the M1 to M4. So what's your thought about what actually, what factors that we need to consider when we think here is the model that we want to test? So are those network models based on theoretical hypotheses or, so what determined the decision that we wanted to use this network model?
So I used this network model because I wanted to do something with 4 variables that was just kind of like a network and I could stick it into path analysis. So this is just completely constructed. The example from depression, so you can fit a network model and there are various different ways to fit either a directed or an undirected network. And there are pieces of software that will that can do that for you with either cross-sectional data or with longitudinal data that will basically estimate what are the most likely relations among the data. And you can get programs that will estimate directions among those variables as well. It's a little bit fraught, right? If you have cross-sectional data, to have a program that comes and tells you this predicts this and this predicts this, well, you know, a lot of those arrows will be going in the wrong direction. So you want to know how to estimate them, or you just, I mean, I guess so you could also have a theory that predicts a particular network, and that would just be this kind of path analysis, right? If you think, I have this construct that represents this other one that represents this other one, so you could test in a confirmative way a particular network structure if you had a theory. Generally, what's more likely to be done is it's exploratory analysis. You have some data, and then some software will estimate a particular network structure from those data.
Okay, well, thank you very much for a great session. And we'll start at 11 on the dot. Okay.